Hello again, my name is Ryan Thomas, and today I'm going to explain why photons, particles of light, travel with different wavelengths. And what it really has to do with is this discovery which I made, which I call spatial matter. And spatial matter is all around us. It's low in density and low in solidness. And one of the things that spatial matter does is it supports all the planets, all the cosmological objects, the stars, moons, and everything, keeps them from falling downward in the vacuum of space. Another thing that spatial matter does is it causes planets and stars to rotate on an axis, and it also causes the orbits, all the orbits that occur in the vacuum of space are due to spatial matter, and it's also what causes gravity. When solid planets form in the vacuum of space, they displace the spatial matter, which then wraps around the planet, pushing to the core, trying to get back to where it was, and that's what causes gravity, the gravity that we experience. That's why we're tethered to the Earth. So spatial matter is all around us, and one of the things that spatial matter does is it causes photons to travel with different wavelengths. And the reason that is because the way spatial matter formed was from the empty vacuum of space condensing and becoming charged material. And that charged material eventually condensed even further and became energy, which is where all the matter comes from in the universe, from that energy that was affected by the Big Bang and became hydrogen atoms when the positive and the negative charges combined to make a hydrogen atom. It's also where how life began, which if you've seen my other videos, you'll know about that. The spatial matter condensed, became energy, and that energy, a lower density form of it, evolved into sentient material. But that's in one of my other videos. I won't explain that in this one. In this one, I'm going to explain why photons travel through this charged material, the spatial matter, with different wavelengths. And I'm going to read directly from my book. It's called What Happens to Us in the Afterlife, the Planets, Moons, Stars, and Other Cosmological Objects of Heaven. And you can see my other videos about that. But this video is going to explain specifically why photons travel with different wavelengths. And it goes like this. So why does light travel with different wavelengths? The reason light particles have different wavelengths is due to how photons are interacting with the charged spatial matter found everywhere. Higher frequency photon particles more actively interact with spatial matter, disallowing a smooth ride through the spatial matter material, which is why higher frequency light particles have a choppier transmission through the medium of charged spatial matter. Higher frequency wavelengths are shorter, which indicates that the faster oscillating particles of light, photons, are more actively interacting with spatial matter, resulting in shorter and choppier wavelengths. Contrastingly, the lower frequency photon particles won't interact as much with the charged spatial matter that's all around, and so it is allowing for a smoother transition through the medium of charged spatial matter, which explains why lower frequency photons have wavelengths that are longer and smoother. Okay, so that's why light travels with different wavelengths. As the photons, which are charged, as they travel through the charged material of spatial matter, they end up interacting more with the spatial matter, and that causes a choppier transition and therefore shorter wavelengths. As the higher frequency photons pass through spatial matter. And for the lower frequency photons, that travel through the spatial matter, they will have an easier time because they're not going to interact as much with the spatial matter material that is charged, and that will affect the trajectory of the photons. So that is why light travels in different wavelengths and why we see colors. Because if there weren't different wavelengths, chances are there would not be different colors, and it would be a very messed up environment for us to live in. So the photons travel through the spatial matter, which causes the photons to interact with the spatial matter, and the higher frequency photons will interact more with the spatial matter, and they'll have choppier transmissions and shorter wavelengths. And then obviously the opposite is true for the lower frequency photons. So that is why light travels at different wavelengths. Again, my name is Ryan Thomas, and you can see my other videos to find out more about spatial matter and about photons and other bits of charged matter that are existing. Okay, thank you very much. Bye.